So I'm going to share my screen one more time here just to remind you of our experiment from 2 weeks ago where we tried to fool our brain. We have an experiment for this week, and I picked a really, really easy experiment. Turn the volume down there because we don't need the volume, but we do need to be able to fast forward a little. So that's what I'm going to do. So with this experiment, it was probably the simplest one we've ever done. We had 3 bowls. In one bowl, we had really cold water. In one bowl, we had really hot water. Not so hot you couldn't put your hand in it, of course. And then in the middle bowl, we had room temperature water. Now, what we did is we put a hand in the cold water for 30 seconds, and we put our other hand in the hot water for 30 seconds. Just kept our hands in there. From there, we took both hands out and put them into the room temperature water. And then what did we feel? Well, what we felt was our hand that was in the cold water felt very hot when we put it into the room temperature water. And then our hand that was in the cold water, our hand that was in the warm water felt very cold when we put it in the room temperature water, which is strange. It's a complete reversal of what our hands were just feeling, especially when we put it into water that should have just been kind of room temperature. So not warm, not cold. So what was going on there? How did we trick our brains? Well, we've got thermoreceptors in our hands, well, all over our body, but in particular, we were looking at our hands this time because we had our hands in the cold, our hands in the warm. So we really activated our warm receptors in the warm water and our cold receptors in that cold water. So we really confused our senses when we took our hands out after 30 seconds and we put them right into that room temperature water. So our thermoreceptors aren't thermometers. They don't say, this is 30 degrees Celsius or this is minus 10 degrees Celsius. They kind of measure relative. So, this is cold, this is warm. So when we primed our one hand to be thinking about really warm with the warm receptors and our other hand to be thinking about really cold with the cold receptors, then we put them both into that water. Our warm hand felt relatively cold because it moved into the room temperature water, and our cold hand felt relatively warm because it moved to the room temperature water. And so that's an evolutionary response. It's really valuable for us to be able to feel temperature changes and react to them. For instance, if you're in the kitchen and you're cooking and you accidentally put your hand on a hot pot and you pull your hand away really quickly. So your body doesn't really ask questions about what temperature is this? Can I keep my hand here? You react. Your warm receptors react. So that's an evolutionary thing. We're primed to react to these temperature changes. And so that's what we did with our body. Even though the water in the middle wasn't hot, it wasn't cold, it was just regular old room temperature water, to our hands that were in really cold water and really hot water, it felt extreme. It felt like the really hot hand was suddenly feeling very cold and the really cold hand was suddenly feeling very hot. So that was our experiment where we tricked our bodies with those different water temperatures. And so again, it's relative. It isn't hot water, it isn't cold water. We don't measure in that way, but our bodies are primed to respond to that change in temperature. So it felt much more extreme than it actually was.